Hi, I'm Patty. I'm going to lead you through this unit orientation video for the fourth grade unit, Vision and Light. In Vision and Light, students take on the role of conservation biologists to learn about population changes in Tokay geckos in the Philippine rainforest. Students figure out why a population of Tokay geckos has decreased since the installation of new highway lights in the rainforest. Students use their understanding of vision, light, and information processing to figure out why an increase in light in the gecko's habitat is affecting the population. Then students turn their attention to humans by designing their own investigations in order to learn more about how our senses help us survive. As they work through the 5 chapters in this unit, they will gather evidence from multiple sources by doing, talking, reading, writing, and visualizing. Their explanations become more complex over time as they construct understanding about how animals use senses to learn about their environment. They discover that light allows objects in an environment to become visible to the eye, and that light receptors in the eye respond to light, causing the brain to form an image. They find out that different animals have light receptors with different sensitivities to light. This unit is an investigation unit. In their role of conservation biologists, students develop skills with the science and engineering practice, asking questions and defining problems. Students ask questions and think about how their questions can be answered when reading informational text and when conducting first-hand investigations. Students also ask new questions after both reading and investigating. Students learn that scientists investigate some questions directly, while other questions can be researched through second-hand sources, such as reference books. In addition, students learn that reading, discussing, and investigating can all lead to new questions. The focal cross-cutting concept in this unit is structure and function. In their role as conservation biologists, students delve deeply into the importance of vision in an organism's survival and to the process of vision as they investigate what's happening in the Tokay geckos. In order to explain why different animals see differently from one another, students are able to connect the shape of the various structures and substructures involved in vision with how those things function. This helps students explain why the Tokay geckos are having trouble surviving in a section of the rainforest with newly installed nighttime highway lights. Students return to the idea of structure and function again and again throughout the unit, using a variety of modalities. Every Amplify Science elementary unit also includes a focal sense-making strategy, which students leverage as they read and also during investigations. This unit's sense-making strategy is asking questions. Like most units in Amplify Science K-5, the main writing genre is explanation. That's the overview. Now I'll talk you through what happens throughout the unit, how students build from their prior knowledge to get to a complex causal explanation of the anchor phenomenon. To do this, I'll summarize the key ideas students figure out in each chapter and how they use these ideas to explain the anchor phenomenon piece by piece. For each chapter, I'll highlight 1 or 2 key evidence sources students use. But remember, in every chapter, and indeed every lesson, students gather evidence multimodally from many different sources. In Chapter 1, students investigate and learn that animals have sensory structures that allow them to learn about their environment by getting information from it. Learning about the environment helps animals survive. Key evidence sources include information gained from exploring how senses help people get information and from reading the book Animal Senses to look at how animals use their senses to help them survive as well. At the end of Chapter 1, students return and apply these ideas to the anchor phenomenon. They explain that in order to survive, a gecko must avoid predators and find prey. To do this, geckos use structures to get information from their environment. For instance, a gecko uses its ears to hear if there are predators nearby and its vision to watch for predators. In Chapter 2, students find out that light allows objects in an environment to become visible to the eye. In order for an animal to get visual information about an object in its environment, light from a source needs to get to the object, reflect off of it, and get to the animal's eye with information about the object. In this chapter, students use the sim to investigate and visualize how light allows an animal to get information from its environment. At the end of Chapter 2, students are able to explain more about how the gecko is able to see. First, light travels from a source to the gecko's prey. Then it reflects off of the prey and travels to the gecko's eyes. As it travels from the prey to the gecko's eyes, it carries information about its prey. In Chapter 3, students investigate and find out that light receptors in the eye respond to light and the brain forms an image. After light from the object enters the animal's eye, it hits the light receptors in the eye. The light receptors then send the information about the object from the light to the brain, which processes the information to form an image of the object. Then the brain compares the image to memories to decide which action to take. Students collect and process evidence through discussions and a think, write, pair, share about the investigation question, as they wonder how an animal knows how to react when they get information about the environment. They use explanation cards to firm up their ideas with a partner before writing. At the end of Chapter 3, students are able to explain that light from a source reflects off of the prey and travels to the gecko's eyes. The light enters the eye through the pupil and then reaches light receptors. The light receptors respond to the light and send information from the light to the brain. The brain processes this information and forms an image. By comparing the image to memories, the gecko can recognize what it is looking at and make a decision that might help it survive. Chapter 4 leads students to discover that different animals have light receptors with different sensitivities to light. If there's too much or too little light for the type of light receptors an animal has, its brain cannot form a clear image. Students compare data about nocturnal and diurnal animals and how they see during day and night, and they create digital models to show their understanding of how different animals see under the same light conditions. By the end of Chapter 4, students explain that when light gets to a Tokay gecko's eyes, the gecko's light receptors respond and send information to the brain. The brain processes this information to form an image. Since the highway lights were installed, there's much more light at night. Tokay geckos have light receptors that form clear images in very low light conditions. So the extra lights at night make it difficult for them to form clear images of their prey. In the final chapter of the unit, students revisit the book, Investigating Animal Senses, to focus on the importance of controlling variables in an investigation. They plan and conduct an investigation of a human sense, and they share investigation results. This experience helps them be able to more independently design an investigation that only changes one variable at a time as they figure out how human structures and receptors inform our senses and help us survive. I hope you're feeling excited to start teaching this unit. In addition to the resources on the Amplify platform, check out the at-home videos and at-home units to help you teach the unit remotely. You can use any combination of these resources to engage your students in figuring out about vision and light. Please let me know how I can help you as you plan for instruction. I'm Patty Works, and my email address is pworks@amplify.com. Thank you.